Hello all, welcome to my YouTube channel. In today video, we are going to discuss about Git, how Git workflow works and some basic Git commands. And in last we will see what is GitHub. So what is Git? Git is a free and open source distributed code management and version control system that is distributed under the GNU General Public License version 2. So here you can see two terms. First is distributed code management and another one version control system. So let's see what it means. So version control system is a kind of software that helps the developer team to efficiently communicate and manage or track all the changes that have been made to the source code, along with the information like who made and what changes have been made. So those all the records will be there. And another terms we have distributed code management. So distributed code management is also known as distributed version control or distributed revision control. So basically it's a form of version control in which the complete code base, including its full history, is mirrored on every developer's computer. So whatever the copy you will have in a server, same copy you will have in your local system. That is called a distributed code management or distributed version control systems. So basically, who founded Linux? So in Linus Torvalds, the creator of Linux, developed and released a Git in 2005. Nowadays, it's being a very popular. So there are some difference between centralized version control system and decentralized version control system. So we have already seen in decentralized version control system. So like every developers has their own copy in a local machine and they can work on it. If so, for example, if you don't have network connectivity, in that case also you can work in offline mode. There is no need to connect to the servers every time. It's required when you need to sync your code with the servers. That time you need a network connectivity or you have a connectivity to servers. But in centralized control version system, what is happen? Whenever you create a new version of your code base, you have to take a latest from the server. For example, you have made some changes on single file, so you have to push those changes to the central server. Then again you have to take a copy of latest because here a concept is single repositories and multiple developers. So in central server, basically we will have a single repositories and multiple developers working on that. So we are not sure like who is making what changes on those repositories. So every time when you make your changes, you have to push, and there are a lot of chances you face conflicts in the centralized version control systems. Because for example, there is a file called B and you also working on the same file and another developers also working on the same file, and when you push your changes on the central server, you can face conflicts. What in distributed cases, what happen, every developers has their own local copy, so you can work on your local copy. Once you complete your code or your changes, later you can, before like in last, basically what you will do, you shrink your changes with the servers. So before shrinking, we have to first take a latest from the servers and then you have to push your changes to the servers. Now we will see how basically Git workflow works. So as you can see in this diagram, basically Git workflow is divided into three states. First one is called working directory, another one is staging area, and third one is Git directories. So basically, if you, in simple words, we can say Git architecture. It's a three state basically. So in working directory, what it is? When you clone the code from your servers to a local machine and you start modifying your code, that is called a working directory. Staging area stays the files and add a snapshot of them to your staging area. Like before, it's a second stage before pushing your code to the server. When you make changes, first you will push those changes to the staging area. Staging area is also a local database basically. And third, we have Git directory, which is called a repositories. So perform a commit that store the snapshot permanently to your Git directories. So whatever the changes you have pushed in staging area, those changes will push to the repositories. So in three stages basically Git workflow works. So if you see in this diagram, this is a central server or central repositories we can call. So from here we are doing a clone operation, and we got a working copy of this particular repositories in our local machine. And here you are doing all the modifications, and after that you are going to review the changes and again pushing to the central servers. So this is Git workflow basically works. So we will see the three-state diagram. Next slide. See here. So first we have a working directory, then a staging area, then we have Git directory or repositories. So first thing will be we have to clone or check out the code from servers to our local. Then you will do all the changes, all the modifications, and you push those files to the staging area, and from staging area you will commit those changes to the Git directory or repositories. Now we will see what's the features of Git. So track history, like whatever or whoever is making changes on the particular database or particular repositories, you will track all the changes. It's a free and open source, support non-linear development, and another create backups, scalable size. For example, scalable. Suppose right now in your team you have 4 developers and they are working on one of the code. In coming future, for example, 20 developers more are going to join your team, and they can also work on that repository. So basically it's easily scalable. As many as developer, like basically n number of developers can work on a single repo, because everybody has their own local copy and they start working on that. Supports collaboration, branching is easier, distributed development. So these are the features of Git. So we will see when Git was not evolved, then what was the scenario, how basically we worked earlier. So in this example you can see this is the branch, business organizations. Here we have 3 developers, 1, 2 and 3, and what they are doing, they are pushing their code onto the central servers. They are not aware what developer 1 is doing, developer 2 is not aware what developer 3 is doing. So they all working on their code and pushing everything on the central server. So there is no history or no tracking, like who made what changes. So basically there was no communication in between these developers. So that's how we worked before the Git. After that Git, we have something like this. Business organization, we have a Git server, distributed server. So everybody has their local copy and everybody is pushing, and it's basically they have a proper communication, like this developer 1 can see the changes of developer 2 and developer 2 can see the changes of developer 3. So basically we can track all these things, who is doing what, and we will easily identify in case of if we found any issues. So that's how we work nowadays. There are some keywords when you work on a Git. You will hear a lot of times, like what commit, branches, clone. So we will see how, like why we use those keywords basically. So what is commit basically? So commit is a snapshot of all the files at a point in time. Every time work is saved, Git create a commit. For example, you are working on a file 1, you made some changes and you saved it. Once you saved that changes, it will create one unique identity, basically unique key we can say. Next time when you make some changes, you will save your work again, it will take a particular unique ID. So it's easily identify like in what ID you made what changes. So we can easily see the changes what we applied on the particular code. Next we have branches. So branches is a version of the repository that diverges from the main working projects. For example, we have a master branch, and there are 4 developers, they are working, they want to work on a different features. So in that case what we can do, we can create a 4 different feature branch from that master branch, and every developers can work on their own branch, and once they complete their changes, they will merge this particular branch to the master branch. That's the purpose of basically branch. Clone clone operation create the instance of the repository. So means you will get a server copy in your local machine. So clone operation not only check out the working copy, but it also mirror the complete repositories. It means whatever the history is it's having in the particular repositories, all these will be mirrored in your local copy, like in your local system basically. Next we have pull. Pull operation copies the changes from the remote repository instance to a local one. The pull operation is used for synchronization between two repositories instance. So basically, for example, when at the time of merge, basically, you because for example there is a master branch and you are working, you have cut one branch called feature one, and you are working on a feature one branch. So when you are about to merge your changes with the master branch, first you have to take the basically first you have to synchronize your changes from the master branch. Then you will. So that's the operation. That's the purpose of pull command here. Next we have push. Push operation copies changes from a local repository instance to a remote one. So whatever you have in your local, that you are going to push to the servers. This is used to store the changes permanently into a Git repository. So whatever changes you have made in your local repositories, you are going to push those changes to the server. Head. This is very important term here. Head is a pointer which always point to the latest commit in the branch. We will understand the latest commit, what it means. For example, again you are working on a file one, you made one changes and you saved your file, it create one commit id. Again you think like, okay, I made some mistake, again you have modified the code and you have made one new, you have shaped again your work, again it will create a new commit id. So once you've done your changes, for example, you are having 3 commit IDs, but the Git will point to the latest commit ID, the last changes which you made. It had basically point to that commit ID. So the head of the branch is stored in this particular location. So this when you initialize your Git repositories, it will create some directory structure in your local machine, and here you can see all those changes, all those what is called a commit ID in this particular location. Now we will see some basic of Git commands. So Git repositories. If we have to create a new Git repository, okay. So create repositories. We use the command git init. Init is just like initialization. If you have to make changes, so these are the commands basically we use: add, commit, and status. Parallel development, again it's a like basically a parallel development, branch, merge, and rebase. So suppose again master branch and you have cut 4 branches, so you are parallelly working on those branches. So for those basically purpose you use these three commands: shrink repositories, push, pull, and add origin. Add origin generally we use for remote repositories. If we have to push our changes to the remote repositories, then we need to add as an origin. Now we will see what is GitHub. GitHub is a website and cloud-based service that helps developers store and manage their code, as well as track and control changes to their code. So in simple words, GitHub is a code hosting platform for collaboration and version control. This is the URL of GitHub. Here we can create a public and private repositories as well. There are few features of GitHub which we will see. Project management. So GitHub is a place where project managers and developers come together to coordinate, track, and update their work so that projects are transparent and stay on schedules. Another one, we have integrated issue and bug tracking. So we can easily track a bug if we have any bugs in our code, we can easily track that bug. Graphical representation of branches. Next, we Git repositories hosting, like we can host Git repositories as well here. Team management. So basically GitHub helps all the team members stay on the same page and organized. Next, we have code hosting. So all the code and documentation are in one place. There are millions of repositories on GitHub basically, and each repository has its own tool to help you host and release code. Next, we have track and assign tasks. So we can easily track the work, what is going on, and we can easily assign the task for like developers or anyone. So that's all the GitHub features basically. So overall, GitHub is a website where we store our code. And so that's all for today. We will see all this git commands which we have seen in the slides. We will see in real time how basically those commands like git, pull, push, branch, clone, how they will work. So we will see in the coming lecture. Thank you for today.